In this video, we're going to talk about the definition of a function, and we're going to start by defining what a relation is because that's part of the definition of a function. So what is a relation? Well, a relation is just a rule that establishes a relationship between two sets of objects, and these can be represented with ordered pairs. So for example, any list of ordered pairs, and I'm just going to make some up here. This would be an example of a relation. You could have an equation. So for example, y equals x plus 1. So that describes the relationship between x and y. Whatever x is, you're going to add 1 to it, and that will give you y. So that's a relationship between those two variables. And then we can also graph those. We can graph an equation. We can graph a list of ordered pairs. And so that's also another representation of a relation. And so we often think of that first object. So I mentioned with the equation, whatever x is, we add 1 to it, and then that gives us y. Well, the x in that case is what we call the input or the independent variable. So again, oftentimes that's considered what we think of as x, and x is also that first number in the ordered pair. And then the second object as the output or the dependent variable. So the y is the second number in the ordered pair. And we have a special type of relation called a function, which is a relation where every input value will lead to exactly one output value. And the important part is the exactly one. Okay, so every input or every x will lead to exactly one y. And so let's look at some examples so we can kind of play around with different relations and whether or not they're a function or not. So with this first example, our first question, we've got this relation where we have a list of ordered pairs, and it looks like our input, which is the first word, so that's our input or what we consider x or the independent variable, that goes to, it looks like the abbreviation or the abbreviation we use in the stock market. So for example, for the company Apple, if we look up that stock, it's abbreviated AAPL. And so what output corresponds to the input Ford? Well, we can just go look at the Ford list or the Ford order pair, and that goes with F. So Ford goes with F. What output correspond with the input Apple? Well, with the stock called Apple, the abbreviation is AAPL. What output would be correspond to the input Google? And so for the company Google, that output or that stock name is GOOG. And then what output corresponds to the input Kraft Foods? So Kraft Foods is abbreviated KFT. And so, and this is just one example. I mean, there are relations that involve, words with meaning like we just did here. And there's other relations which are like just a list of ordered pairs like I did above, which don't have any real world context. But the important question here is this relation a function? And so we have to ask ourselves, does every input lead to exactly one output? So for example, with the company Apple, does it have more than one abbreviation? Is there another order pair that has Apple going to a different output or a different abbreviation for the stock? And the answer is no. And so we're going to say yes, this is a function because every input goes to exactly one output. Okay, so now let's look at a different relation, and we're going to look at this relation B here. And this, is just a list of ordered pairs. It doesn't have any real world context, which the previous example had. And so we're going to go through the same set of questions like we did in part A. So what outputs correspond to the input 9? And so we're just going to find 9. It looks like 9 goes to 0. And we want to make sure that there isn't another 9 here also, and there isn't for an input. There's a 9 as an output, but there's only one 9 as an input. So 9 just goes to 0. If there was another order pair with 9 as the input going to a different output, we would list that output as well. So it's possible to have more than one answer there. What outputs correspond to the input -1? And so we look for -1, it's right here. It looks like that goes to 5. What outputs correspond to the input -3? Looks like that goes to 1. What outputs correspond to the input 3? Now here we have two different ordered pairs that have an input 3. We've got 3 going to 9 and 3 also going to 3. So we're going to list 9 and 3 here. And so this last question asked, is this relation a function? And in this case, we say no, because our input 3 goes to 9 and it also goes to 3. And the definition of a function says that each input can only go to one output. So we say no, this is not a function. So let's look at the second example, example 2. So consider the relation person in an airport goes to their legal name on their ID. So that's the relationship. Those are the two sets of objects that we're looking at. So person in an airport and then their legal name on their ID. Is this relation a function? So you need to ask yourself, is every person in the airport assigned to one legal name on their ID? And I would say yes, every person has one legal name. And so I'm going to say yes, this is a function because each person is assigned one legal name and only one. So yes, it's a function. And then example 3 says, consider the relation each person in the airport is assigned to their nickname, or we're looking at those two variables there. And is this a relation a function? So we need to ask ourselves, does every person in the airport only have one nickname? And I would say, well, no, it's totally possible. I mean, it's possible that a person has no nickname. It's possible that a person has one nickname, but it is possible that somebody has two nicknames. So I'm going to say, no, this is not a function because it's possible for a person to have multiple nicknames. So I hope this helps, just an introduction in terms of what a function is. In the next video, we're going to talk about how to look at equations and determine if they're a function or not.